Hello, gentlemen. Welcome back. Hopefully you guys have a good understanding on Chapter 3 and are now ready to jump into Chapter 4. And we're going to start by just doing a couple sections in Chapter 4. Hopefully some of the stuff that we're going to do at the beginning is going to be somewhat of a review for you, especially the idea of radians and degrees and different types of angles that you should have saw in geometry and probably a little bit in Algebra 2 as well. So let's get underway. And again, understand that trigonometry is a huge part of calculus and stuff that you're going to see next year. So really getting a good foundation here is going to be critical. Let's talk about radian and degree measures. Let's get some terminology down. This is called our initial side. If we're looking at an angle here, our initial side, and this is called our terminal side. Okay, and there is some angle measure. We'll call it alpha. Okay. And so when we talk about measuring angles, this would be an angle in standard form here. Okay, all angles in standard form are going to get measured off of the positive x-axis and positive being counterclockwise. Okay, so if I have an angle here and I'm measuring off the positive x-axis and I'm going this way, that's going to be standard. All right, I'm going to have a positive angle that way. If I go in the opposite direction, or if I go clockwise, that angle would be negative. So for example, this could be something like 2 pi over 3, and we'll understand what that, whoops, let me go back there, let me get my pen. This angle here could be something like 2 pi over 3, positive, and this could be, say, negative, I don't know, pi over 3. I'm not overly accurate there, but you get the idea. Positive is going to be going counterclockwise, negative when we go clockwise. Always off the positive x-axis. We have we talk about coterminal angles. Coterminal angles are such that they have the same initial and terminal sides. Okay, one can go in the positive direction, the other can go in the negative direction. I can actually go around a couple times. Remember that for degrees, I can keep going around over and over again. So I can have, hopefully you know that all the way around once is 360. If I go double that, 720, all I'm doing is going around twice and ending up back to where I started. Okay, so coterminal angles have the same initial and terminal sides. We need to talk about radians. You need to understand about radian measures. You're going to see this a lot in calculus, and I suspect that a lot of your work so far with angles has been through degrees. So it's going to take some practice, but make sure you understand radians, because if not, you're going to have some difficulty in calculus, because in calculus very rarely do we talk about angles and degrees, except when we're doing word problems. Well, let's define 1 radian. Okay, we're going to define 1 radian is the measure of a central angle right here, theta, that intercepts an arc S right here in equal to the length of radius r. So S is equal to r. So this is the definition of 1 radian. Okay, and we're going to talk about arc length a little bit later, but that's the definition of it. All right, and it's important that you guys understand the unit circle and where things are on the unit circle. Okay, you need to know where pi over 6 is, pi over 4, pi over 3. You need to know these, and you're going to need to memorize them for sines and cosines. I'm going to say it over and over and over again, actually for all your trig functions. But understand where you are on the unit circle based upon these different values. Let's talk about some different types of angles. We have acute angles. Acute angles are between 0 and pi over 2 radians. Okay, we have obtuse angles, which are between pi over 2 and pi radians. Okay, you've probably learned this, and hopefully you know that pi over 2 is equal to 90 degrees. So this would be between 90 degrees and 180 degrees. Okay, but again, I want you guys to get in the habit of understanding radians. 2 angles are complementary if their sum is pi over 2 or 90 degrees, and 2 angles are supplementary if their sum is pi or 180 degrees. Okay, And here you can see what the figures look like. Let's do an example here. Find the complement and supplement of the angle pi over 6. Okay, so basically what I want to do here is I want to find what angle do I add to pi over 6 to get pi over 2. Okay, and again, if I was to do this, I skipped some steps here in this, but if I was to do this out, I would get a common denominator. I would have 3 pi over 6, which is the same as pi over 2, minus pi over 6, which is going to be 2 pi over 6, which you should know you can reduce down to pi over 3. Okay, so that's how I would find my complementary angle. To find my supplementary angle, I want to go from pi, so I want to go pi minus pi over 6. Okay, you'll see that come out here. And if I look at that, I can think about this as 6 pi over 6 minus pi over 6. And that should give me 5 pi over 6. Okay? Hopefully that's pretty straightforward. So finding complementary and supplementary angles isn't too challenging. We talked about coterminal angles. Coterminal angles have the same initial and terminal side. There are an infinite number of coterminal angles. I can just, like I said before, I can look at just a simple example here. Okay, this angle here, whoops, here is pi, right? If I go this way, I can go to negative pi. My initial side is right here. My terminal side is right there. But I could also say that this is 3 pi, because 3 pi is going to do what? There's, whoops, there's pi, there's 2 pi, and then if I come back, that's 3 pi. Okay? So I can have an infinite number of coterminal angles. How can I find some? You can add plus or minus 2n pi. So in the example I just did, I had pi plus, I let n equal to 1, 2 pi, and I got 3 pi. Okay? I could subtract 2 pi. I could say that pi minus 2 pi equals negative pi, and we saw that that was also a coterminal angle for pi. So there's an infinite number here. If I want to find two coterminal angles for this, 2 pi over 3, I can add 2 pi. And again, if I do that, just check doing your math, this is going to be 6 pi over 3 plus 2 pi over 3. That's where my 8 pi over 3 comes from. And I can subtract 2 pi. I get negative 4 pi over 3. And if I look at what that looks like, here's 2 pi over 3. Here's negative 4 pi over 3 going in the clockwise direction. 8 pi over 3, fellas, is going positive. And understand that if I go all the way around once, that's 2 pi. So if I start here and I go all the way over here, that's 3 pi over 3. If I come all the way back over here, that's 6 pi over 3. And then I go another 2 pi over 3 to get to there. Okay, so all of these here are having the same initial side and terminal side, all describing the same angle. Let's talk about converting from radians to degrees so that you guys understand that. You should understand that 1 revolution is 2 pi radians, and you also should know that that's 360 degrees. I can use that fact to say that pi radians is equal to 180 degrees. I could use this to convert from radians to degrees, or vice versa. So if I want to convert from degrees to radians, let's get rid of that up there. If I want to convert from degrees to radians, I'm going to multiply by pi radians over 180 degrees. This is a multiplying factor equal to 1, right? They're the same. Pi radians and 180 degrees are exactly the same. So, for example, I have 60 degrees. I have 60 degrees times pi radians over 180 degrees. The degree term cancels. It's in the numerator than the denominator, and I'm just left with pi over 3 radians. Okay? If I have 135 degrees, again 135 degrees, pi radians over 180 degrees, the degrees cancel out, and I'm left with 3 pi over 4 radians. Alright? If If I want to go in the other direction, if I want to convert from radians to degrees, I just switch this. Again, because I want to get rid of the radians. Again, this ratio here is equal to 1. It's the same. I'm not changing the value. I'm just changing the units here. Okay? So if I have pi over 6 radians, I would take pi over 6 radians times 180 degrees over pi radians. Radians are going to cancel out, and I'm going to be left with 30 degrees. Okay? If I do another one, 3 pi over 2 radians, again, radians are going to cancel out like that, and I'm going to get 270 degrees. Okay? Here's some reading I want you to do. It's not the whole first section. Look at these first couple examples. Here are some practice problems. These should be pretty straightforward. Finding complementary and supplementary angles, coterminal angles, and switching from degrees to radians and radians to degrees. Okay, and then I'll do another video on the second part of section 4.1, and then we'll be almost ready to wrap up the third week. Okay, fellas? Let me know if you have any questions, and have a good day.